Okay, now let's take a look at our second strongest intermolecular force, dipole-dipole forces. And again, these only occur between molecules that have a dipole. Again, it's electrostatic attraction, but again, this is between our permanent dipoles, between one permanent dipole and the permanent dipole of another molecule, so between two polar molecules. If we take a look at an example, for example, HF, we know that fluorine has a much higher electronegativity than hydrogen. This is not a symmetrical molecule, and so therefore this molecule is polar. If we're to draw that dipole arrow, we would show it pointing towards fluorine because it has a higher electronegativity. Electrons are spending more time around the fluorine. And what ends up happening is the negative part of fluorine is attracted to the partially positive hydrogen of the other molecule. Now again, for this force to occur, unlike London dispersion forces that occur in all molecules, these molecules must have a dipole. They must be polar. And again, just a reminder, if you want to figure out if something's polar, draw the Lewis structure, figure out the shape, figure out whether we have bond dipoles, and then figure out if there's an overall molecular dipole. In terms of boiling point and melting point, when we have a larger or a stronger dipole, aka a larger difference between my lower electronegative element and my higher electronegative element, it slightly affects the boiling point and melting point by increasing it. If you take a look at this 3-carbon molecule and compare it to the 4-carbon molecule, because there is that dipole there, this molecule is actually liquid at room temperature. It has a higher boiling point. In terms of solubility, this one's a little bit different than London dispersion forces in that the greater the dipole, the more soluble it is in water. So if you take a look again at those exact same molecules, the one with the dipole is soluble while the one without the dipole is insoluble in water. And this is due to this idea that is known as like dissolves like. So water is a polar molecule, and so it's able to dissolve other polar molecules.